right, so I went, I went through the notes real quick, and I didn't do stuff last weekend. A bunch of stuff I didn't get to last weekend, but freeze this. Okay, so y'all, so there's a couple of things that you may still have to turn in. The ones that I've not gotten to, I've not graded Gailey Sachs law yet. Then there was the all of them together from Friday. What we're doing is what we did last week, with smushing them together. That's why it's called the combined gas law, is because they combines the three little gas laws. So since we have to know this, what is normally the unit for volume? Okay, you guys are used to saying milliliters and liters still, and that's still okay today. Wednesday, when we start the ideal gas law, it's going to have to be in liters. Okay, but for right now, if they're both in milliliters, that's fine. What's the unit for pressure? Pressure. What are pressure units? Torr. Atmospheres. Millimeter mercury. There's one more. Kilopascals. And just like before, if it doesn't matter which pressure unit it is, as long as it matches. No. And then on Wednesday, our pressure, millimeters of mercury, torr, kilopascals, and atmospheres. Stop throwing stuff at each other. Now, oh, what? Kilopascals, Kilopascals. Just give KPA. KPA. Liter is not, it's okay if they're both in milliliters still, but like I said, on Wednesday, they have to be very, very, very specific. We have to be in liters, we have to be in atmospheres, and then for temperature, what's the unit for temperature?
Kelvin.
Kelvin. Okay, now it's going to normally be given to you in Celsius. How do you get from Celsius to Kelvin?
Add 273.
You add 273.
What's pressure?
Pressure could be kPAs, mmHg, torr, or atmospheres, ATM. Yes, wait until George comes back. He's got the pass though. Oh, if you're on way over there. We are doing the combined gas law. A little bit of vocabulary stuff first before we get into the formula. Gosh. Our gas laws are based on something called an ideal gas, which doesn't exist. Okay, but temperature's Kelvin. Mm-hmm. Now, the kinetic theory of gases is for an ideal gas. And I just said that ideal gases don't exist, but it has a law. And so there's a couple of particular things about an ideal gas. There's no volume, and they're not attracted to each other. And so they don't really exist. Okay, but the laws are what we use to be able to calculate the relationships between pressure, temperature, and volume. Even though ideal gases have no volume and they're not attracted to each other. We still follow this law. Now the formula today is going to take, and I just printed my stuff out. I am very much behind for this week in both of my classes for that matter. There's not much for you guys to write down. Right, ideal gases follow the gas laws all the time. You
I go back.
go back.
No, I get the last one.
Okay. Well, we know in order to measure, it has to be present. Okay, so obviously we're going to be dealing with volumes, and they're going to be contained in something. Otherwise, if you pop a balloon, the gas just goes everywhere. Okay, so the hard part is manipulating this one today. Now, with the little laws, we did Charles' law first, right? So V equals V, 1 over T1. This was the first one we did. And then we did Boyle's law next. And then the last one we did was Gailey Sachs' law. Most of you didn't have a hard time rearranging this thing. especially since I gave you the answer. With the two proportions, you multiply the ones that were diagonal and then you divided by the thing that was left out. With Boyle's law, the inverse relationship, you either need both ones or both twos, and you went ahead and multiplied them and then divided by the other one that you had. Most of you did not have a huge problem with this. The problem was, is it really a 1 or a 2? Well, you're going to know 5 of the 6 today. You're going to know 5 of the 6 variables today. And this is why we did the little ones individually first, is to get you comfortable with manipulating the formula. It's not hard math. You're just moving stuff around. If it was originally multiplied, when you take it to the other side, it's going to be divided by. And if it was divided by, when you take it to the other side, then it's going to go up in the numerator, and it's going to be multiplication. Why not? Why not? It's going to be more rearranging your formulas and trying to fix that today. Because the ones before were simple. This isn't, like I said, it's not same exact stuff you were doing before. It's just all at once. Hold on. You needed to go get your Chromebook? Is that right? She asked me. She has to go with that. Is anybody still copying this one down?
Can we still take that test?
Wait, yes, hold on. I'm gonna do some arrows.
I have to reopen stuff.
Well, I just saw your email saying that we all made that test. Maybe.
Yeah, sometime a while ago. Wait, who's this? This is.
I'm gonna check.
What are you watching?
This is me, huh? Jared, turn it off.
Put it on the real and put it up on the school calls.
What are you doing? Why do you have that help?
Huh?
You, just pay attention and focus for a change. Today is the.
Did Chloe break up with you, Sarah?
Nice. Wait, last finish, what one? Okay, I'm gonna finish this last one.
Hold on, let me finish this and all.
Yeah.
What's this? Okay, so y'all should be ready. All right, we're going to take a look at each one of these individually. Maybe you didn't get it the first time around, even though we've been doing this repeatedly. The first one that we started with was Charles' Law. Okay, where it's, now I just didn't, I wrote it linearly. So the V's are in the numerator and the T's are in the denominator. So it's the first volume divided by the first temperature equals the second volume divided by the second temperature. This just made it easier for me to put it linearly. Boyle's law was the second one that we did. Now, Charles and Gay-Lussac's are directly proportional. That means if one goes up, the other has to go up. Boyle's law is an inverse, which means if one goes up, then the other one goes down. And this is the one that said that P1 times V1 equals P2 times V2. We're just sort of going back over these because it's been the weekend. And your test, which will be in a week, not Monday, I think it's Tuesday. It's almost, I haven't even looked at it yet. It's going to be mostly math. Because it's not good. You know, I wrote down the dates. I wrote down the dates.
Next week is next month.
What's the day?
It's 29.
May. No, they're not till May. No, English, well, you're not
Ours
doing
is
English
the-
1 and 2. Which test are you guys taking? Algebra?
English 2.
English
We only take
2?
English 2.
That is April the 13th. No, wait. This is
It's
all
April 8th.
so jacked up. April 8th. Virtual is April 13th. All these different dates, because they're doing in-person versus remote, and like,
That's fine.
it is all kinds of crazy. All right, then the other one that I couldn't fit on here, Gay-Lussac. Sorry, a lot of my little.
No, I didn't know you were writing the formulas.
Okay.
Tiffany, are you like, you okay? You are never like this.
No, it's
That's
not.
usually me.
Pay more
acting
attention.
like that. I think.
Pay more attention.
Me? No, okay. I'm gonna talk to
I
you.
always
Usually
say
it's me like that.
keep- I'm always here.
I'm just trying to get the answers from somebody else, I just
so-
don't have to go back. And be slaughtered. Good, task force.
You did it?
Yeah.
Yep, okay. Okay, and then the last one that we did of the baby laws is daily tax law, which is a proportion, directly proportional, but this is pressure and temperature. Now, we're going to shove them all together. You're going to combine them. So this is the combined gas law, which does all three of the individual laws. V is still pressure, so they have to match. V is volume, they have to match. If one is liters, the other one has to be liters. And then the T is temperature. You just need to add 273 to Celsius. It's not any harder. You're just gonna do 5 of the 6 bits. It's the rearranging part that you're gonna probably have to have help with. And we will have a work day tomorrow. The only reason why this one's stapled is so that you would have room to be able to write out your stuff. I give you the answers. I think I gave you the answers. Should have.
Yeah.
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 You gotta show your work.
I'm still probably gonna fail.
Mr. Ritchie, if you give us a birthday, why do you give us one birthday?
Because some of you will already be done.
Oh, really?
You will. And now the one that I have is not a packet for tomorrow. It's a single sheet. It's like, I actually have 2 of them. I don't know which one we're gonna do.
It makes no sense. You give us a birthday, but then you give us one birthday.
Mhm.
It makes no sense.
What's the point of this?
That's the point of the workday, is to make sure that-
Work on all the work you've missed.
You should be able to keep up with them. Besides, I'm giving you the answers. Right, we're gonna go through some sample problems. Okay, you may be the kind of person that needs to highlight, underline. You need to identify all of your variables. Yes. Yes, I forgot. So the pressure on 5 liters of the gas goes from 760. Well, this is only gonna do 2 of them. This is only the relationship between pressure and volume. So if I rewrite, forgot we did the individual ones first. If I rewrite the combined gas law, the whole thing. No, they can't see me drawings on the board. Is there temperature in this problem at all?
No.
No. So you're just going to ignore that it's even there. This is a Boyle's law problem. You only need to use the full thing, the T1 V1 over T1, like the whole thing, is if it's talking about all 3 of them. In this case, now I'm showing you how to rearrange it first. You might be the kind of person that needs to put your numbers in first and then rearrange. I don't, whichever way you're more comfortable with, do it that way. So either you're going to want to rearrange and isolate the variable first, or you're going to plug everything in and then you're going to rearrange for the unknown thing. In this case, we've done these. This was last Wednesday, I think, when we did Boyle's. You know both of the ones, so you're going to multiply them. You only know one of the 2, so that's going to end up going in the denominator. Once again, when you take a variable to the other side of the equal sign, it's going to do the opposite function. And right now, all we're doing is we're multiplying or dividing. There's no, well, you might have to change from Celsius and add 273, but other than that, there shouldn't be any addition, subtraction. So if you do this right in the calculator, the only thing that's left unit-wise is a liter, and this is 5.63 liters. I'm gonna keep it the same amount of 6/5 as the other volume.
You have to go through all of these.
Huh?
You have to go through all of these.
We're gonna go through all of them, yeah. This is reinforcing each individual law, and then I'm gonna do a couple of them that does the whole thing.
This is just less time you are working.
If I do not show you how to manipulate the full ones, you're gonna be confused. You will. Okay, so next one, we have temperature and volume. There's no pressure listed here. So if I take a look at the combined gas law, if I just cut off the P's, This is a Charles law problem. You just need to add 273 to Celsius. Now, it's going to 250 degrees Celsius, so that is my T2. You're going from 0.25 liters, that is an initial, that's a 1. You're going to 1.20, that's a 2. And then you're just going to drop everything into the formula. This is one where you would cross multiply the two that are diagonal and divide by the thing that's left out. You do it right, you get 110K. I need to check my online attendance. It's just show, some of you need to see everything step by step by step. And this is how you are going to be doing your work because you have to, otherwise you get confused. Some of you, if your math skills are a little bit better, once you set it up in a proportion, you sort of skip this step. You know that you should multiply the things that are diagonal and divide by the one that's left out. You just need to show me what you're doing. Let me check my lines. Let's see. Okay, just Declan and Reagan. Lucas, no, Veronica. No, Bailey's not here. Oh no, George, you're present. Let's see. Okay, go here. Hayden's here. I'll get going in just a second. Okay. So like I said, these first few are more refreshers. Okay, the next one we're going to do, you still writing it? Okay. I'm just going over one of each, and then we'll do 2 combined. It's, like I said, we've been doing this, it's just now all at once. I'm hoping to be done in 15 minutes. So, got it? And so that means that I'm going to do a Gay-Lussac's problem with you. I have at a pressure of 1.25 atmospheres at that specific temperature, I'm going to call those my ones. Then we're going to do the infamous throw the can into the fire, which you should not be doing at home. Okay, and it's going to get really, 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 really hot. So that is a 2 temperature. You just need to add 273. Don't throw aerosol cans in the fire.
I already did.
I can't make any promises. I can't keep up them.
So,
I did that when
well,
I
they
was
can
in-
blow up in your face. That T1 should have been over just a little bit.
I've already
So-
caught
See,
myself.
that's
on-
okay.
I sure did. I've already caught myself on fire.
Okay, so
Um,
to solve for P2, you're going to multiply these and divide by T1. And like I said, some of you are going to want to plug in numbers first and then rearrange. Some of you are going to rearrange and then plug in numbers last. It's the same thing. It's just whichever you're more comfortable with. And then I think it's a whole number.
what just happened? I'm kind of-
So at pressure of 1.25,
I am dumb as hell.
no,
Oh,
you just need to add 273 to your Celsius. This, after you throw it in the fire, it goes to this temperature. So this is a T2, T1,
I'm messed up.
P1. You're solving for the new pressure. And so that was, honestly, we had an assignment for each one of these separately, then on Friday, it mixed them all together. I didn't tell you which one it was. You really only need to know this equation because it will do all of them. If there's something that's not in the problem, or if it's constant, it's not changing, it's not gonna be part of your math.
I messed up because the P1 and T1 were like kind of close and I got confused.
Confuddled?
Dang, yeah.
Puzzle.
Dang.
Confuddled? Oh gosh, the pollen is so horrible right now. Now, when we do the one on Wednesday, if they're not in the right unit, you have to convert it to the right unit to use the rate constant. I'm not teaching you 4 rate constants, I'm teaching you 1, so you're gonna have to do a lot of conversions. Every now and then I'll give you a problem that's straightforward, it's already in atmospheres, it's already in Kelvin, it's already in liters, but if it's not, you gotta make it that way first, then you can, right? Okay. Okay, so here's where it gets a little bit more complicated. Volume of 235 mils at 15 degrees Celsius and 784 millimeters of mercury. I'm going to call those my ones. Okay. The volume, there are 3 ones. Then the volume goes to 600. So that is my V2. The pressure goes to 1,500 millimeters of mercury. That is my P2. I am solving for my T2. This is where it just gets a little bit more complicated. This is in the denominator. I do not want what I'm solving for in the denominator. Now, y'all, when I say trust me, please just trust me. These are going to switch places with each other. To get rid of T2, I'm going to multiply it both sides. So it's going to go up into the numerator. You're going to pull T1 up into the numerator to get it off the bottom. And then to get T2 by itself over on the left-hand side, I'm going to drop my P1 and my V1. I do not want this in the denominator. This is what I'm solving for. Okay, so if you have had crappy math teachers, I'm sorry. If you're trying to solve for something in a denominator, it's going to switch places with the stuff that's on the other side of the equal sign in the numerator. In this case, the P1, they're just going to switch places with each other. Okay? But I don't want this in the denominator on this side. My whole point is to isolate T2 by itself. So this is going to move up into the numerator with the P2 and the V2. You want T2 by itself. The problem is it's down on the bottom. And apparently, whoever was supposed to teach you how to manipulate formulas did not do a very good job. I'm just being honest. It's okay. I mean, when I teach, even when I was teaching pre-AP physics, I had to take time and do this with my students. The whole first few weeks was nothing but manipulating formulas without numbers in them. Just the letters like this. So I do not want T2 in the denominator. Huh? Your V2 is the 600 milliliters. So the first 3 together, and they're both in mils, so you're okay. 235 mils, 15 plus 273 is my T, and 784 millimeters of mercury. Those are all my ones. The V2 is 600. That decimal is just there to force sig figs. My P2 is 1500 millimeters of mercury. What I do not know is my T2, and it's going to be in kelvins with the math. It's just more at once. We've been doing it. So I'm going to do P2 times V2 times T1 divided by, and then you're going to have to use parentheses in the denominator. You're not going to get the right answer. I do have some students that will multiply out the top, write it down, multiply out the bottom, write it down, and then be top divided by bottom. That'll work. But with this particular problem, my face is so itchy. No, I'm not crying. It's just allergies. It's at least I'm not sneezing like I was this morning. It was disgusting. So when you go to put this in the calculator, it's 1500 times 600 times 288 divided by, you would open parentheses, 784 times 235, and you would close them. 1400 Kelvin. It's not, I mean, if you want to multiply out the entire numerator separately from the denominator, then do the final answers, then you can. The more times you hit enter with a calculator, the more chances there are for human error. You push the wrong button, it didn't register a decimal, you put in too many zeros, I don't know. But no, this, you have to be able to manipulate for a variable. And if it's better for you to throw numbers in first and then move them, do it that way. 1400 Kelvin. If I wanted it in Celsius, I would subtract 273 from this.
This is too much.
I didn't, and there's a reason why there's a workday. Okay, I've got one more I'm going to show you. I know all my lines are not animated. I just caught that I didn't animate them. Like, pick the people that were remote were actually watching me fix it. All right, we have a dry, let's see, we have a dry gas. It has a volume of 1.25 liters. It's at 100 degrees Celsius. I have to add 273 and 880 millimeters of mercury. These are all my ones. Okay. Then all it tells me is I want to know the volume, so I'm solving for V2 and standard temperature and pressure. Okay, so same formula. To solve for V2, I'm going to throw T2 up in the numerator with the P1 and the V1, and I'm going to bring P2 down into the denominator with the T1. You're just doing the opposite function when you move, because you want V2 box up. Well, it's already up in the numerator, so it's not as much work. But your T2 will go up top and your P2 will go down bottom. And that's everything that I know. Now, it says you go to standard temperature and pressure. Standard temperature is 273 Kelvin. In this case, if it's in millimeters of mercury, standard pressure 760. If it was atmospheres, it would be a 1. If it was kilopascals, it would have been a 101.3. The only thing that makes these difficult is you have to make sure everything matches. You have to make sure that you're in Kelvin. And it's how the heck do you move stuff around to be able to solve. So I'm going to do P1 times V1 times T2 divided by, this is when you use parentheses, open parentheses, P2 times T1 and close them. Or like I said, you could just multiply them out and then do it that way. You just have to take your time and make sure you're keeping your ones with your ones and your twos with your twos. If you do not divide with parentheses, then it's going to divide by 760, store that answer in its little calculator brain, and then multiply the entire thing by 373. That's not what you want to do. You want to divide by both of them together. So if you do put this in the calculator correctly, you get 1.1 liters. Now, they're not hard. They take time. And I put the answers on the side. I don't think I made any errors. There are 9 of them on here, but they're going to take you a few minutes to do each one. So I do have a work day tomorrow. I have an extra paper. It's not as long. I don't know which one I want to do. Well, they're all the same thing.
The one that has less.
That's what I'm looking to see. First of all, did I put answers on them?
It might all be easy for you because
Well, I mean, I've been doing this for forever. This one has 6 and this one has 6. So it doesn't really matter which one I would do. Yes. They do.
Which one feels less complicated?
They're all the same thing. It's unfortunately with this type of math, the more that you do them, the easier it becomes. And some of you were pretty comfortable with the ones that we were doing last week. And we got what, 15 minutes in here?
Can I try to find this tomorrow?
Yes. So I was going to ask, is there anybody with the one? Let me stop the recording here first. Is there anybody that had a question with one of the ones that we